Okay, now we will do our second example. A car leaves a bus station and travels 55 miles an hour. A bus leaves the same station traveling in the same direction, traveling 65 miles an hour half an hour later. How long will it take the bus to overtake the car? So again, the first thing I'm going to do is just organize all my information. So I have one line for the car, one line for the bus, and for each of those I'll try to find out what the rate, the time, and the distance will be. So first of all, the car is going 55 miles an hour. That's easy. And the bus is going 65. Okay, let's look at the time. Okay, car leaves the bus station and travels 55 miles an hour. I've got that in the chart. A bus leaves the same station traveling in the same direction, traveling 65 miles an hour, half an hour later. Okay, so if the car has been traveling for a certain amount of time, the bus has been traveling 30 minutes less than that. So that would be t for the car's time and t minus 0.5 for the bus's time. If you were tempted to write t minus 30, remember that we need to measure time in hours. Since the speed is given in miles per hour, that means my time has to be measured in hours. So I can't have t minus 30 because that would be 30 minutes. I'd want t and t minus 0.5 or t minus 1/2. Now what do we know about the distances? Well, let's just draw a little bus station here. So we have this car and it goes that far. And then half an hour later, this bus comes along and it overtakes the car. Look at the green line and look at the red line. Okay, if the bus and the car leave from the same station and the bus overtakes the car, they've gone the same distance. They are equal. So I'm going to put D in for the car and D in for the bus. They are the same distance. Okay, so now I've got my chart filled in. That's the first third of the problem. The next thing I want to do is get equations. What do I know about rate, time, and distance? Rate times time is equal to distance. 55 times t is equal to d. And again, 65 times t minus 0.5 is also equal to d. So my first third of the problem was to organize my information in a chart. The second third of the problem is to get those two equations. Rate times time equals distance. Rate times time equals distance. Third part of the problem is to solve. Again, this is set up beautifully to do substitution. So we'll say 55t equals 65 times t minus 0.5, and I'll distribute, giving me 55t equals 65t minus 32.5. Subtract 65t from both sides, so I have negative 10t equals negative 32.5. And divide both sides by negative 10, so t equals 3.25. So 3¼ hours after the car leaves, the bus will overtake it. Since 3.25 is how long the car has been traveling, that's kind of what we look at. Now, one thing to be careful of, that 0.25, some people will say 3 hours and 25 minutes. Notice that 0.25 doesn't mean 25 minutes. That's 0.25 of an hour. Technically, that's 15 minutes, but as long as you say 3¼ hours or 3.25 hours, I'm fine with that. Okay, that is our second example, and the next example will be in the next movie.